You're trying to get people to come in and see it.
Yeah.
Just yeah. Right. All right. I'll try and right. If anyone wants to come and hear about the Rosetta space mission, I've just come back from mission control and I'm about to start a very short talk on the mission to a comet, which finished yesterday. So it's happening just now around the corner. Do my best? Yeah, a minute, couple of minutes, yeah? Yeah, a couple of minutes. Yeah. Oh. So we're starting in a couple of minutes. I'm just trying to round up a few more people and then we'll get going. Shall I start? Great.
This is Sue.
Yeah. Right. Hello everyone. My name's Sue Nelson and I'm a science journalist and I specialise in space and space science probably because I was a massive Star Trek fan, had a huge crush on Captain Kirk and I was hooked on science from then on. I'm still hooked on science fiction, I have to say. And also when I was a teenager I wrote to NASA and I said, I want to become an astronaut. How do I do it? And they wrote back to me. I told them that my favourite subject was physics and they said, keep studying it. So I did, got a physics degree. And what they didn't tell me was actually at the time, NASA didn't admit women astronauts in the early 1970s. So they were very good in encouraging me, but not actually letting me know that they weren't going to have women for quite a while after that. But what they did include was some technical specifications of their new vehicle, which is the space shuttle. So that sort of definitely got me hooked onto all things space. And so for me, it's a joy to be able to work, not for NASA, although in fact I was at NASA Houston in May making a BBC programme, but for ESA. Who knows what ESA stands for? You will know. Yep.
European.
Yeah, good. Now, at one point, reporting on space, I was a BBC science correspondent for 8 years and used to do a lot of the reporting on the space missions for TV and radio. In the journalist newsroom, a lot of people didn't actually know, a lot of journalists didn't know what ESA was and would say the ESA or something like that. And I think that shows you how at least it's moved on, that people know thanks to the Rosetta mission what the actual ESA stands for. And this mission actually began an enormously long time ago. 2004, the Rosetta spacecraft took off in this Ariane 5 rocket from French Guiana, which is in South America. And although it's in South America, that is actually the European spaceport. So that's where a lot of European missions and spacecraft will launch from. They also sometimes launch from Baikonur in Russia. But for many of the scientists, that mission actually started even before then. Some of them were planning that mission in the 90s. So you can see how for the people who work on it, it's often the culmination of decades of work. And myself included, I reported on the launch of this rocket in 2004. And in fact, I even did a report before it launched. And then the Rosetta mission wasn't going to comet 67P Churyumov-Gerasimenko, which is the comet that it was. It was actually going to a different comet. It was going to comet Virtanen, I can't even say it now, Virtanen or something like that. But because there was a slight fault with the rocket, the launch was slightly delayed. And comets are moving things. Comets orbit around our sun. They go round through our solar system and around the sun. So you imagine how you've got to coordinate. Everything's moving, the Earth's moving, the whole planet, all the planets in the solar system are all moving at different speeds. You've got to time your launch so that as your rocket is going that way and then releases the spacecraft and out it will go, your comet is moving too. So you've got to plan your trajectory so that they meet. Well, when the launch was delayed, it was too late. The comet, by the time the spacecraft got there, the comet they originally intended for would have gone by. So they had to choose another comet. And that's why they ended up with the one that yesterday, I don't know whether you've seen it in the papers, the Rosetta spacecraft did a crash landing, not too big a crash, it was about walking pace, but it actually landed on the comet yesterday for the end of its mission. And that's where I've come from this morning, from Mission Control in Germany at Darmstadt. And this is it. This is what Rosetta is. Rosetta is actually the name of the mission, but it actually refers to two things. The orbiter, which is this big thing here with the solar, each one of these solar panels, these wings, is 14 meters long, which is quite considerable, probably almost the length of this room. The actual square bit in the middle, that's the Rosetta orbiter, because that's the one that's been orbiting. So when they talk about Rosetta orbiting, that's what it looks like. And this little thing, which is about 1 meter square, that's the Philae lander. That's the lander that landed on a comet a couple of years ago and sent back some science. And they've been doing great animations, if you've seen it on the web, of the comet itself. And this is its journey. To get there as well, we're talking about the thing, it had to have little kicks of energy, effectively, from the Earth and from Mars as well. So it used the atmospheres of both planets and the gravity as a sort of gravitational little kick start, a bit like getting a stone and go whoomph. It just increased its speed to get out to the comet. Now, it's been busy along the way. In 2008, it flew fairly close to this. It was only one of them. These are just different images of them. Asteroid Steins, which everybody thought looked slightly diamond shaped. And one of the useful things they discovered at the time actually was that one of the cameras, the Osiris cameras, wasn't working as well as it should have been. And you can see this is slightly, it's not quite as in focus. But that was great because it enabled them to do some little checks. Because what they can do with spacecraft is if they find there are little glitches, a bit like apps on your phone, you do a software update. Except it takes just a little longer to send your signals out to a spacecraft, but it can update the software to improve things. So a couple of years later, when it flew by asteroid Lutetia, there you can see how amazing that looks like. And it actually, somebody mentioned the moon before, it does look a little bit like a sort of barren, cratered moon. And these are the people, the comet is called, and this is for any journalist is the worst thing ever. You have to keep saying Comet Churyumov-Gerasimenko, Comet Churyumov-Gerasimenko, Comet 67P Churyumov, and they're people's names. Comets are normally named after the people that discovered them. And in this case, they're two independent discoverers, I think. In 1969, they discovered the comet. So it's after their surnames, Svetlana Gerasimenko and Churyumov. Now, all that time, 2004, so 10 years later, they are hoping that their spacecraft will wake up. And the reason it had to wake up is because during this massive journey that Rosetta was going on outside in the solar system, the further away it is from the sun, then you're not getting much power to its solar panels, and you can't afford to sort of power up all your instruments on board because they need power. So it went into hibernation in 2011. So at this point, it was quite a crucial point for the mission. It was 10 years after launch. It had been asleep for almost 3 years, and they had to wait for a signal to see if it would wake up, send a command signal. And as you can see by how happy they are, obviously it worked. And this was at the Mission Control in Darmstadt. That's Andrea Akamatsu, the flight director. That's Paolo Ferri, who's spacecraft mission operations. That's ESA's senior science advisor at the end there. And it was a fantastic moment. And it's a great one to to actually report on and as a journalist. There were some surprises though, because the closer it got, they then got their first sort of, glimpse of what comet Churyumov-Gerasimenko 67P looked like. Now this is sort of the shape they expected. They expected a potato shape, because that's what most comets, although you see these beautiful images in the sky of the light and a lovely long tail, that's probably the most beautiful that comets look like, because the closer you get, the slightly more plain and potato-like they look. So this is the shape that they were expecting of the comet, a potato. But that's what they got. And this is it, slightly upside. See, it had a sort of head and a slightly bigger body. And everyone realised it looked a little bit like a rubber duck. See on the side there? It was more like a rubber duck. And it's not that big. It's only about 4 kilometres, so it's about the size of a small village. Obviously, if that fell on you, you wouldn't like it. And there's the lobe. And what they also discovered, the closer they got, that actually this comet was actually made of 2 bits of rock that at one point had collided together. And that's why you got this unusual shape. And immediately the space, the engineers are all thinking, oh my goodness, well, we were expecting something round. And if you're a spacecraft and you're going to orbit the comet, which is what Rosetta had planned to do, first time it's ever been done before. They also wanted to land on it, never been done before. A controlled landing anyway. NASA have smashed something into, but not like this. You'll then got a few problems because you're not quite sure of what the gravitational field is going to be around a duck shape. It's going to be slightly uneven. So it was a very good challenge for the scientists that were actually working on it. And it meant they had to do really good models of their comet. And the closer they got, the more accurate their models of the little duck-shaped comet could be, that they could do it. There are 21 instruments on board that spacecraft. There were 11 on the orbiter, the one with the big solar wings, and there were 10 on the little Philae lander. And this is one of the, PI stands for, they always call them PIs, it means Principal Investigator. You'll hear in NASA as well, they say the PI, the Principal Investigator. So Fred Grossman, he's in Germany at the Max Planck Institute. He was in charge of the Kozak instrument. Give you an idea of how committed they are to their work. He had that belt made especially for him. Holger Six, he's also based at the Max Planck Institute in Germany. He is the OSIRIS camera principal investigator. So those amazing close-up pictures, a lot of, that you've seen of the comet's surface, have been done by the camera. And this is what that camera looks like. The great thing is when you go and interview all these scientists, they usually have an exact scale model of the instrument with them. Not least because they want to, if there are unusual conditions, they want to test what's happening with their instrument and see if it's working and responding to the same commands. So these lovely colours, they're the different filters that are on the camera. And here's some of the images of the comet's surface as the spacecraft got closer and closer that camera was able to take. And you can see that there's different types of terrain. Some of it looks quite cliffy and rocky, and they found pits as well. And whereas this looks more like a desert, doesn't it? Like a sand dunes. And in fact, they found one of the instruments. They basically put radio waves through it, almost like radar, through the comet to see what it was made of. And they found that it's really, you think it, because it looks rocky, you think of it as very solid, but it's really porous. And they described it yesterday as bits of it being like fluffy snow. That porous. It's got lots of holes inside. And in fact, that they also reckon that 4 kilometre long comet would float because it's that light, because it's so porous, got so many holes in. But also some bits are porous, they're more like sand. And you can see how it's more like a sandy world there. Here's one of the women scientists who was in charge of the Rosetta instrument. And you can't quite see his face here, but this is a British guy who was the project manager on it, Matt Taylor. This was taken the day before Philae landed, which is why there's the Anchorman reference on there. See, he's always had a bad taste in shirts. So, and this is how devoted Matt is. His body is covered with tattoos, devoted to the missions he's worked on. So he worked on the cluster mission, and that's on his... Is that on his other leg? Yeah, on his thigh, massive cluster. Now, the cluster mission was a collection of spacecraft, so he's got lots of them all over. And so you see he had this done before Rosetta landed, so he got the lander and Rosetta there. And as a result of that, in the press kits that were given to journalists, we could have our own Rosetta tattoos as well, but temporary ones, and put on our own tattoos for the occasion. And this was some of the images from that event. So I was really lucky, for somebody who's a bit of a space geek like myself, to actually go there. I do a lot of work for the European Space Agency making their films. So if any of you have watched any of their short films that are on the web, on the ESA website or YouTube, or if you watched the live feed yesterday, you will have seen some films about the mission. Then I made those. So it's like a dream come true for me to actually be involved in that and make them. And this is what it's like. Often the reality is never quite as glamorous either when you're there, although it's fantastic and I get to go in mission control and see what it's like. When you're actually working there as a broadcaster and a reporter, it's very much, your job is to... In my case, it's to watch the feed, usually in an OB van. So it'll be in vans like this. So BBC News were there, Sky was there, Sky at Night was there. There were all the broadcasters from the whole of Europe there, because space is an international discipline. And this is inside one of these OB vans. This is where everything is directed from. So you've got cameras in the control room. The scientists are actually doing, their own job, and then you've got directors in a van trying to get everything so that it all comes together. Inside the European Spacecraft Operations Centre in Darmstadt, Germany, where they set up for the landing a massive model of the comet. That's the duck on its side, so that they could actually get people into, all the scientists in, to share it and see if it would land successfully. And this is where I was yesterday. This is actually where the flags are there. You can see the Swiss or Canadian flag. They have different things. The entrance is there. And this is the building where the mission control is actually in. And I discovered yesterday that this little sign here was a Pokemon stop. So I was really happy. I got some Rosetta action. And there's the Andrea Akamatsu, the flight director. So this is the great thing, if you're reporting on stuff, you get to go inside mission control as well. And it's nowhere near. I was in the Houston mission control in May, and they're huge things. These are the mission controls that are for the International Space Station and stuff like that. It's much on a smaller scale at ESA, but it's no less exciting when you know that it's actually not just the Rosetta spacecraft that's being controlled from the control room. They actually do multiple. They're doing different, they might be doing Earth observation satellites, weather satellites. There is actually, in a couple of weeks, another European Space Agency mission that's going to Mars called ExoMars mission. So that will all be controlled from here as well. And for us, we have to film the scientists to get interviews with them. And it's about translation and communication as well, because what they're doing is very technical. But what you want them to do is to explain what they do in language that everyone can understand. And they get better and better at it. Now, this was the site, this was the picture that was taken from the spacecraft. It released its little lander, Philae, the legs came out, and that was the picture that the spacecraft took as it was going down to the comet. And it was a success, and that's the first time anybody on Earth has ever done that. And brilliant, it was done by Europeans. we did it. I meet people there, British, Irish, you name every nationality, you hear every language, and the language they all work in is English. And in fact, when you have to get scientists who work on the missions they give you an interview in English, and then if they're Italian, you then ask them the same questions, a few of them that they give you the answers in Italian, so that the Italian broadcasters can use it in the native language. If they're Dutch, often the Dutch can speak French, German, they can speak loads of languages. If they're German or what have you, they'll do it in German. And because they're so used to their everyday language is English, they actually find it much harder to explain what they've just done in their own language. And they often forget the words for the different instruments and the scientific things because they're so used to just using English. And this was another world first for the mission, the first ever image from the surface of a comet. So when that lander landed, this was the first picture it sent back. And there's a little bit of its foot, so you can see one of its legs. And it perplexed people for a while because they didn't quite know what was going on. And that was because, as it turned out, that lander didn't just land as it was supposed to. When it was going to land, each of its 3 legs had harpoons that were going to shoot out and then attach themselves to the surface. Well, they didn't fire. So when that lander came down on its 3 legs, it went bounce, 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 and then it came to rest. And it came to rest, as we only discovered just a few weeks ago. It was exactly as they thought it was, based on its position, the pictures it was taking. It was in a cliff, beneath a cliff, in the dark, and on its side, with its legs up in the air as well. But it still managed to do. It was only ever intended to do 2 to 3 days worth of science. And it did 60 hours of science. So actually the scientists still got pretty much, I would say 95% of the science that they intended to get back from the lander. And this is what it's like afterwards. After everybody's got the information, they've seen it, they might have watched it online. It's mayhem because everyone's desperate to try and get interviews with the scientists from all over the world. But it's also, it's one of great achievement because there's these scientists who could have been working on that mission for 20 years and it could have all gone wrong, but it didn't. It all worked. But since that date, it's actually got better and better because the spacecraft, the orbiter, has been going around that comet. It's spent 2 years accompanying a comet as it gets closer to the sun and then moves away. Something that has never been done before over such a prolonged period of time. Oh, this was a celebrate. There was a bit of a champagne drink afterwards to celebrate. And the landing was even celebrated, but if you went on Google on that day, that's what you would get on your search thing. Because there is an instrument called the Alice instrument that is NASA scientists. So a lot of people don't realise that actually you get a lot of European Space Agency scientists work on NASA missions, and you do get, although this is a European mission, it does include a few NASA, and they're the principal investigators on the Alice instrument, the NASA guys. Here's Matt. I mean, this is something when you're a journalist that you never guess that a story. Do you all remember what happened as a result of this? An amazing achievement, and unfortunately, because of the state of undress of the women on his shirt, which was actually it was a gift from his friend, a woman who'd made it, and I sort of see it as more a PR problem because I've got to know Matt quite well as a result of working on this mission. And you couldn't get a more right-on guy than Matt, and he's very supportive of women in science. But I would just say it was definitely an inappropriate shirt for a work meeting, maybe a private party afterwards. So he got a lot of stick for wearing that from women who saw that as not helping or encouraging women in science if you just see half-naked women on his shirt. But he was genuinely sorry about that and recovered well, which I'm glad about. There he is. And this is, they have the scientists have a meeting because they're all different nationalities and there are different European Space Agency bases all over Europe. They will meet together to discuss the science they've got so far at different points around the world, which is lovely because it means I've been to Madrid to film the scientists where they've met there. This one was at Rome. The most recent one in June was slightly less glamorous. That was Milton Keynes. But they're all good. They're all good. And the summer of 2015, now this was important because this was the period of time when the comet was the closest to the sun. Now, comets serve, lots of ice, dust, gases coming off. The closer you get to the sun, that's when everything's going to happen. The heat from the sun is going to melt, and this is where you get all these jets of gas and ice and material and dust coming off. And so all while this was happening, you had the spacecraft going around it. It had to go at a slightly further distance because one of those jets could have knocked the spacecraft out. So it had to go slightly further away to get it, so you get it in full duck form. But they've discovered, over the last couple of years, the number of gases from this. It doesn't smell terribly nice. One of the gases is hydrogen sulfide, which is like a bad egg smell. But they've also found lots of organic material. And one of the reasons for wanting to study comets is because a comet like this one formed around 4.6 billion years ago. So it's at a time when our solar system's forming. So when you learn about a comet, you're actually learning about us, who we are, where we come from, who we are, how the Earth formed, why we're here, how did it happen. So you really are getting a sort of a time machine into our own history and our own past by looking at comets. And one of the organic material, they found glycine, an amino acid, on the comet. That had never been found on a comet for the first time. Because one of the theories is that potentially comets could transport some of the ingredients that are necessary to life to other planets. So it could be, for example, that although we're all on Earth and, we're formed here, that actually we could all be alien, in that the ingredients for our life could have been brought from a comet from another part of the solar system. So it's finding out things like that. What they did find out, though, from this particular comet is that the water that was on this comet and the ice is not the same water as you find on Earth. So it could be that a comet may have brought water to our planet, however millions of years ago, but it wouldn't have been one like this. But so scientists are still learning and understanding and trying to work out and revising their theories, because that's the thing about science. It's never definite. It's always being revised and upgraded, and more is being learned about what's going on. There's Matt again. So this was actually just a week or so ago. This was just before we went. STEC is the technical facility where they test all the spacecraft in Holland, and that's where Matt's based. So this was shortly before the final part of the mission, which happened yesterday. This is just to give you an idea of what, for them, it's all about. It's not just, doing amazing journeys, spending 10 years getting there. It's all about science and learning about ourselves. And the amount of science that they've got from this mission will keep them busy, they reckon, for 20 to 30 years. So it could be that, some of the younger people in the audience, if you become a scientist and want to do space science, it could be that you do a PhD in information and data that has come from this mission. Because there is so much, that's how long it's going to take to analyse and go through it all. This was the latest just a few weeks ago. I mean, it's hard to see it really. But see that little red square there? That's where the lander was. And there you can see it up on its side, because they thought Philae was lost. They tried so many times, but every time they thought they were going closer and they were using the camera, and every time they thought they'd found it, it turned out to be a boulder. And you can understand why they couldn't find it, because that is really hard, isn't it, to actually find. So it's a lovely ending to this mission, is that finally the orbiter, Rosetta, has found its lander and knows where it is. The final place for its resting place was also on the head of the duck. See that top bit there, which was also where the fillet was landed. It wasn't that far away from it, but not close enough that as it was coming down to its descent, that it could take pictures of it. So that's the only and the best photo that we'll have of the lander where it is. And so they made this lovely decision to end the mission. Okay, let's do something we've not done before. Let's do a controlled crash landing down onto the surface of the comet, taking pictures along the way. Some instruments were switched off because obviously you're losing power, but they kept the main ones that will get the most out of it as you got closer and closer to the surface. And that's what happened yesterday. The night before last, they did a couple of 3 thruster burns to get it into the right position, and then it began a really slow descent down to the surface. And this was taken yesterday at Mission Control, so you got these hot off the press. This was the van where we had to do all the editing that's inside. Say it's not so glamorous, is it, as being in Mission Control there with all the material there. That was what I was doing with the ESA TV production office, and that was it. And there were a few tears, actually. Some of the scientists were very emotional because it's the end. But having said that, a lot of them were also really looking forward to spending the next few years, possibly 10 or more, working on the data that they've got from this comet. They've got information about the gases that come off it, the materials, the gravitational field, the tail of the comet, the density, the structures, the materials. So it's a huge amount of work. But what I did get told, which is really interesting, is that, okay, the Rosetta orbiter is no more. It was switched off as soon as it landed. Dump, that's it. It's now dead. But Philae, the lander, was never actually switched off. So potentially, one of them told me yesterday, who knows, in the future, there could be another mission. It could be jolted from under its cliff. And as it comes, it takes about every 6.5 years, that comet comes around the sun. When it gets closer to the sun, because this comet is changing shape every time, when it gets close to the sun, loads of bits go off it. So it's changing and losing in mass. That if the sunlight falls on Philae, we could see a little hello lander back again. But for now, I think we can all be very proud that Europe and a lot of British scientists, one of the instruments that's on the lander, was made and built in Milton Keynes at the Open University. So, lots of people don't quite realise that we do space, and we do space really well. Thank you.
Got any questions for Sue?
Mm-hmm.
I watched this on BBC News 24 Live yesterday lunchtime.
Yeah.
And as you said, the emotions were quite high.
Yeah.
Were you actually in the room at that time? In which case, what was it like for you?
No, I wasn't in the room then. I was in the van doing the OB stuff, the broadcasting stuff, getting it. The people I spoke, I went to the Rosetta after party last night with all the scientists, where they had a massive chocolate cake in the shape of the duck, the comet, a big comet chocolate cake. And a lot of them then they said actually that for some of them, when it was actually announced it was all over, they didn't quite know how to react. So it felt a bit almost flat. Some of them were too stunned to actually say anything. And it probably wasn't, they said it wasn't until hours later. And for some of them, interestingly, they said it was only when they saw the animation that really got them for some reason, that they were, so they were much more relaxed in the last night in the evening, possibly because there was lots of German beer and wine. I couldn't possibly comment, but you know, they were much more, you know, much more emotional about it. It's a huge part of their lives. But for some of them, you know, it really is. Some of them work on. One guy I was speaking to last night said, he had been working. Oh, I know, the XMM mission, which is an X-ray, some sort of X-ray. I can't remember what it stands for. X-ray mission. Anyway, it's some sort of X-ray. He's been working on that mission for 28 years. And often you'll find that they work on different missions in parallel. So some of the same, one of the guys who worked on Rosetta, Fred Janssen, he is now working on ExoMars. So they often have several missions running along in parallel. I mean, it's a fantastic job, you know, that they're doing. And also, because often, like the scientists at the Open University, a lot of the instrument they built for Beagle 2, which everyone thought had been an absolute disastrous fail, and then it turned actually no, it did land on Mars. It was all there. It was just that the solar panels hadn't opened. A lot of that technology and expertise they gained from that has really helped them in other missions, and you find that if something has worked, like a gas analyzer, for example, has worked on one mission, then they then transfer it to another, and they will then get asked as well. They have more of a chance because they have to bid for them. It's quite competitive, really. You're competing with other scientists in your field who all want to build an instrument on board a mission, and the best idea, you know, wins. And if you can prove, oh well, we managed to get ours to Mars and it was fine, then you've got a better chance of getting it on.
Thank you.
Yeah.
Do you know why they switched Rosetta off as soon as it crash landed? What's the reason for switching it off?
I think they just wanted it to, from what I gather, it was to just have an end to it, but also they didn't want something that could potentially just be sending out signals the entire time, you know, in space going around, you know, sort of thing. They just wanted, and that they felt was the most sort of fitting way to end it.
Could it be that there was a comment yesterday again that said if it flew past and they sent it off, to get so far out that the fuel would freeze?
Yeah.
Was it a case of they don't want to litter up space anymore?
Oh, I don't know. If you look around the Earth, it's pretty littered already, actually. Yeah, so, I mean, that's another issue, actually, is how to get rid of space debris. I think that, and there are European ideas about doing that as well. Some of them involve a net, believe it or not, like a massive net, and catching and sort of, you know, trawling. Instead of fish, you get all these dead satellites that are orbiting. Yeah. Yep.
The mission lasted 12 years. Where are the scientists planning to go from here?
Yeah, well, some of them will transfer onto other missions, but what they a lot of them, particularly the ones who are on the operational side, who are the ones who are working out the trajectory, so, and the engineers are doing the mathematics for how to do the orbit of the spacecraft. Well, that's their work definitely over. The ones who are involved with the instruments, they've got all the information and data that their instruments collected. There's so much of it that they're now going to keep going through it, and so they'll be doing what they'll be getting, you know, the hands dirty with the science now to see. So expect that probably over the next year or so, every so often in the news it will be, oh, they found this from the Rosetta mission, and that will be why, is that they're working through all the information that they've got. But yeah, some will already be working on other missions, and as well as working on their Rosetta stuff. Well, thank you very much indeed. And I see we've got a few under 16s here. If you would like, I have from European Space Agency, I have a little Rosetta badge. If you would like one, please come forward and I will give you one. Would you like one? Would you like